All right, this is going to be section 3.3. This is all about lines. You're going to see a lot of this is going to be review, so it should be pretty straightforward. The first thing, some vocab here, we'll talk about slope. The slope of a line is basically just the steepness of a line. And down here, it says the larger absolute value of the slope, that gives us the steeper line. So here in a little bit, we will talk about lines, steeper lines, even if they are going maybe different directions. The biggest thing with the slope formula, the order does matter. Remember, with distance and midpoint, it wasn't quite as important. You could kind of go a little bit either way. With slope, you do have to be a little bit more important. You have to be consistent. So whichever one is your first y, it's got to be your first x. Whichever one's your second y, it's got to be your second x. So you got to go in that order. Okay. The next thing we will look at, sorry guys. The next thing we'll look at is just some examples of finding slope. Okay, so we're going to just take, remember this is x, this is a y, this is an x, that's a y. So I'm just going to subtract my y's. And then because I went this way, I've got to go the same thing with the x's. Go ahead and simplify, and then we'll just go ahead and reduce this fraction, so we get -1/2 as our slope there. Second example here. Same thing, y minus y over, go in the same order, x minus x. Okay, on the top we get -5, on the bottom we get 0. Remember that anything divided by 0 is undefined. Okay, that is a slope. There is no such thing as no slope. If you put no slope, that will be incorrect. There is always a slope of a line. A lot of times it's going to be a number, like this first example. Or we could have a couple things here. And this HOYVUX, H-O-Y-V-U-X, is kind of a good acronym that we're going to remember. There is one typo, so if you'll go ahead and change the x's and the y's need to be flipped there. Okay, so in this case, or in this example, we see that it's an undefined slope. That would tell us eventually that we would need to graph a vertical line. It'd have an undefined slope. And then if we were to find the equation, it would be x equals 4, just kind of as a heads up. All right, the next thing, we're going to sketch a line. So we're just going to go ahead and put this point on the graph. So there's the point, 2, 1. When we talk about slope, we talk about rise over run. So 5 over 3 can be +5 over +3. That means we're going to go up 5 and then go to the right 3. So there's one dot. Now if you'll notice, if I try to do that again, I'm going to be off the graph. I'd really like to have more than 1 point or more than 2 points. So -5 over -3 is actually the same thing. That reduces to 5/3 also. That means we're going to go down and left. And there's enough points. Now we can connect that and make that a pretty good line. All right, we're going to talk about a few different forms of equations. The first one is point-slope form. So with point-slope, one thing I want you guys to maybe pay attention to is right here, this y minus and the x minus. Right? That comes from part of the equation. So once we go to answer, your final answer, that's going to be in your equation, y minus and then x minus. Now all these things in green, that's where you're going to put those 3 numbers. So to use this equation, we've really just got to find 3 things. We've got to find the slope, and then we've got to find an ordered pair and just plug it in. All right, so if we look at this equation, it says find, or this example, find an equation through these 2 points. Now, we need some more information, so if we can find the slope first, that's going to be helpful. So we're going to get 5. 1 minus -3 is 5/4. Okay, so that gives me the slope. These are points. Now, it doesn't tell us what form. It just says find an equation. So I'm going to probably want to use the easiest equation that I can. And in this case, it's going to be point-slope form. So I'm going to go y minus. I'm going to pick, I'll just use this first point. Y minus 7 equals my slope. Remember, x minus comes from the equation, x minus 1. Okay, that is a perfect answer. Now, we could also use the other point, y minus 2. The slope is still the same. Now, this one becomes x minus -3. That's x plus 3. If we were to graph both of those, you would see that they are the exact same line. We could turn that into point slope form or slope intercept, which is what we're going to talk about here in a minute, but it's actually going to be a little bit easier just to leave it this way. So slope intercept is just y equals mx plus b. Again, that's what you guys have been, you've looked at that a ton before. Same thing. The y and the x are going to stay in the equation, and we're going to find numbers to put in for our m and our b. All right, so this one's already, this is actually in general form or standard form, and we want to get it into slope intercept. So that means I want to get the y by itself, so I'm going to subtract 2x from both sides. Now I do want to go ahead and keep it in that same order. I'm trying to get to mx plus b form, so I would rather just keep it in that same order. Those are gone. Let's see, negative divided by negative. And then that becomes minus 8/5. So then we're able to look at this and see that our slope is 2/5. Our y-intercept is negative 8/5. And we'd be able to graph that really easy. Sometimes if we're graphing, negative 1.6 might be easier to change it into an integer when we're trying to graph on the coordinate plane. The next form we're going to talk about is general form. Sometimes it's also called standard form. Okay, here's what standard form looks like right there. Basically what that means is the x and y are on the same side, and then the constant is on the other side by itself. A lot of times when we're using standard form or general form, we're going to graph using the intercepts. So I'm going to find the x-intercept and the y-intercept. I'm going to use what's called the cover-up method, where we're going to basically just cover up the stuff we don't need. So remember, for the x-intercept, we only care about the x, so we're going to cover up the y, and so then all I see left is right there. For the y-intercept, I only care about the y, so I'm going to cover up the x. Go ahead and solve that. X is 4, so go ahead and put a dot on 4 for that y-intercept. This is negative 8/5, which again is not real helpful, but if we put negative 1.6, that's going to be a little bit more helpful. Just somewhere between negative 1 and negative 2. And from those 2 points, you have enough information to graph that line. All right, next we're going to start talking about parallel and perpendicular lines. Parallel lines just means they will never intersect, and we know that they're going to have the same slope. Okay, so this example asks us to write a new equation through a certain point, and it's parallel to this line. All right, now it doesn't actually tell us which equation to use, but I'm looking at point. We're talking about parallel, so I'm thinking if we can use point slope form, that's going to probably be the easiest. Now I need to find the slope of the existing line. So I want to go ahead and get that into slope intercept form. Subtract 6x from both sides. I'm going to go ahead and divide by 3, and I'm actually going to stop right there on that work, because all I care about right there is that the slope is negative 2. I really don't care about the y-intercept of my other equation. Now we're able to go ahead and plug it in, so y minus negative 7 is y plus 7. There's the new slope, x minus 5. Now that's an okay answer. Real quick, just so you can sort of see what we would do if we needed to get it into a different form, maybe slope intercept form. We'd go ahead and distribute there. And then let's see, y equals mx plus b, so then I'm going to subtract 7 from both sides and get y equals negative 2x plus 3. Now you do see that the slope is the same as over here, which just kind of reinforces that we are probably okay. Perpendicular lines. Remember, perpendicular lines are going to meet at a right angle. Their slopes are going to be opposite reciprocals. So it's going to be a two-step process. First, opposite means one's going to be a plus, one's going to be a minus. Reciprocal just means we're going to flip top to bottom. Now, if you have two equations and if you have two slopes, an easy way to decide if they are perpendicular is just to multiply the two slopes. If you get negative 1 as an answer, then they are perpendicular. This is actually the same information from the previous question. So I knew my slope up here was -2. But then when I go to do the opposite reciprocal, I'm going to switch it so I know it's going to be a positive, and then I'm going to do my reciprocal. Now remember, -2 is really 2 over 1, so when I flip it, I get 1/2. I'll go y, I'm sorry, not y equals. Let's see, point slope form. And it doesn't say what form it needs to be in, so that's okay. If we needed to put it somewhere else or something else, we could do that. All right, the last example. The last example is pretty much a review, just pulls everything together. Perpendicular bisector, and then also we're going to do general form. So we got a bunch of information here. The first thing we're going to look at is perpendicular. Okay, perpendicular means I need to find a slope and then do an opposite reciprocal. So my original slope looks like this. So I'm going to get -8 over -3, which is 3 over 8. But I need the opposite reciprocal. So now my new slope that I'm going to be working with is -8/3. Okay, the perpendicular part is done. Now bisector, that's what we'll do next. That's just another word to say midpoint. So midpoint, we talked about this a couple weeks ago. Remember, x plus x divided by 2? And then y plus y divided by 2. That's going to be 2 over 2, and then 5 over 2. So now 1 and 5/2. All right, that's actually enough information to go to point slope form. So I'll go y minus 5/2 equals -8/3 x minus 1. Now, that would be awesome, and we could stop right there, except our question says get it into general form. Okay, that means we need to get all the x's and the y's together on one side, and then usually we're going to get rid of all of our fractions also. So I want to distribute first. All right, and then I just talked about wanting to get rid of fractions. Now, this goes back to way before, or quite a ways away, or before. Okay. We're going to look for our least common multiple and multiply everything by that to take care of our denominators. So I got a 2 and a 3. I'm going to multiply everything by 6. So if we multiply everything by 6, I get 6y. All right, keep going here. Let's see, I'll just multiply the numerator. So 5 times 6 is 30 divided by 2. So that's going to be -15. All right, 8 times 6 is 48 divided by 3. That's going to be -16x. And then that'll be +16 also. Now we got to get the x's and the y's on the same side. So I'll add 16x. I'm going to go ahead and add 15 to the other side. And there we go. Now we are in general form, because the x's and the y's are on one side by themselves and the constant is on the other side. That is the end of this section. So that was 3.3 lines.